आप मुझे भैया बुला सकते हैं. So my name is Sayan Saha. I think you got it from the thumbnail. And today is the first video of physical chemistry. Welcome to our channel Dreamacademia. All the things related to the physical chemistry syllabus and how we'll proceed, all that timeline I will be giving in a separate video. How you should study, how to make a good timetable, efficient timetable, and how we can follow it, and all motivational things and all informational things I will give it in a separate video. So today is the first day, so let's start. And yes, my Hindi is a bit weak, so don't make memes, okay? I will be communicating with you in Hindi sometimes, but meme mat bana lena bhai, please. So, what is here? You see, there is no elevator to success. You have to take the stairs because you see, there are 10 lakh per, what can I say, aspirants who give jeemains exams. If you ever stop in this place, right? If you ever stop to think that someone will take me up, no one is going to do that. The teachers, your parents can at least form these side walls, all the railings, to guide you that you have to go in this way, but you yourself have to climb up with strain on your thighs. Means you have to put effort yourself, you have to keep yourself motivated every day. Otherwise, you see, to succeed in these stairs you need to leave behind 99% of the students behind, because after getting 99 percentile you will get CS or something 98 also, but you have to leave behind 98% of people, right? So you have to climb really fast and in an efficient way such that it does not slip in any steps. Okay, so let's start. So what we will be studying today, we will study today the laws of chemical combinations. From JE point of view, it's a bit important. I'll say how the questions come in JE, but it is not so much important. Only one question you can expect in JE mains, and I haven't seen any question of from coming of this in JE advanced. So just focus for your one JE main question. So there are 5 laws of chemical combinations. What are they? First is the C. First is the law of conservation of mass. वेरी बेसिक, ये तो सब जानते हैं, गब्बर भी जानता है. So and next is the law of constant composition or the law of definite proportions, and then comes the law of multiple proportions, the law of equivalent, reciprocal or combining proportions by weight or weight, Gailux law, don't laugh, okay, Gailux law of gaseous volumes. Okay, these 5 things we'll study. You say that we have to memorize the names. Yes, because the questions come in that way. They will just give an assertion of, means they will work out an example and you will ask which law does it define or which law does it comply. So you need to remember the names for if one questions comes in JMA. In my time it came, that's why I'm telling you all. So let's start from the first law. It's very basic. I think you are reading this from class 7. What can I say in this? Law of conservation of mass. It states, it was given by Anthony Lavoisier, you know. It states that during the course of chemical processes, matter is neither created nor destroyed. For example, if masses M and N of substances A and B react, there are two substances that are reacting, suppose oxygen and hydrogen, and their masses are M and N that are reacting. Means you have given some, suppose, extra of hydrogen, but no, the mass that is reacting, means how much hydrogen is reacting, that you have to take in consideration. Substances A and B react to form masses X and Y of substances C and D. Suppose hydrogen and oxygen reacts to give water H2O respectively. You have to calculate how much water is formed in the beaker. May there be, suppose you are conducting experiment, you are mixing H2 and O2, and after you're putting pressure and the water is formed and some remaining H2NO2 is remained. Now you have to evacuate that H2O2 and you have to measure, okay, the water is formed, or you have to react you have to ensure that all the O2 and all the H2 has reacted. Okay, so m plus n equals to x plus y, very simple. It follows that the total mass of the reactants is equals to total mass of the products. It's so simple. Here is nothing there to explain. So see, here you know, now you know that CH4O2 methane plus O2 CO2 plus H2O. This is a combustion reaction, right? Okay, first let us balance. I will be telling you some of the techniques how to balance this reaction easily. So first you check that from this CH4 in the product where carbon is there. Only one place here. So you just balance the carbon here, carbon atom. How many carbon atom is here? One. How many we need here? One. So it is okay. Now you go to the second atom, hydrogen. How many hydrogen here are? Four. And what is the source of hydrogen in the products? Only water, only one compound, H2. Okay. So very easy. You need to only balance this one. There is four, there is two. So give here two. Okay. So now is four. Now we come to the remaining atom, the oxygen. So how many oxygen is the product side? 4 plus, sorry, 2 plus 2, 4. Okay. So how many you have here? 2. So to make it 4, multiply it with 2. You will find some formula like this. X, suppose X is the number of carbon and Y is the number of hydrogen. So here it will be X plus Y by 4. Okay, and one thing, if you think that I am going slow, please increase the speed of the video because time matters. It really matters. If you are comfortable with 1.5x speed, watch in that. Okay, and here it will be x CO2 and here it will be y by 2 H2O. Okay, simple. How many? 4, and here it is y by 2, right? So now next. So, and what we are concerned about, the masses. You see, it is very silly that conservation of mass. You can see that the number of carbon atoms, what happened? The number of carbon atoms here, the number of carbon atoms here, we have balanced. So the mass of carbon atom is remaining same here also and here also. So the conservation of mass will definitely be followed, right? Suppose you are with your friends, your weight is X, and now you are with your, with your, let's, okay, dash dash dash, and so what your weight will be? Same X. So here carbon is with H4, its weight is X, and here carbon is with O2, here also its weight is X, and we have balanced the number of atoms, so obviously the mass will be balanced. Nothing to say here. Wait, one very funny thing that I used to imagine in class 7. I think you know the E equals to mc square. I somehow came to know about it in my class 7. Okay, and I thought that if there is some energy, it must come some from mass. And combustion reaction is an exothermic reaction, so some energy will be produced. Now my teacher was teaching this law of conservation of mass, and he showed this amount of energy. Now I am thinking that if from the reactants the masses are remaining same, then from where this extra energy came? I was literally confused. Some mass must be converted in some energy. It's very silly of me, right? Because the bond energies, it changes. So enthalpy, you get it here. You will learn about enthalpy. What is enthalpy? I will teach you. So don't keep this confusion in you, okay? So let's move. It's the balance. Let's balance this one. So I will be teaching you some small things also in the between what we are learning. So here it is 6. It is 6. How many carbon we need? 6 carbons. Okay, and how many hydrogen we need? 6, and we have 2, so multiply it with 3. Nice. Now how many oxygen we have here? 6 into 2 12, 3 into 1 3 means 15, and we have 2. So to make it 15, I'll first divide it with 2, okay, and I will multiply it with 15, right? Is it okay? We need 15 oxygen atoms and we have 2, so I will divide it with 2 to make it 1, and I will multiply it with 15. 12 plus 3 15. Now we want to keep it a whole number, so multiply it here, okay? So finally you get, okay, I am writing here 2C6H6. I think you got it. I need no need to write. Plus 15. I think I am writing with mouse. That's why I am writing so slow. Okay. Next, from next day I will be writing on the screen, so no problem. And you multiply 2 12 CO2 plus 6H2O. It's that much simple. Okay. You don't need to remember this formula. Okay. Here also it will come. See, x is 6. 6 plus y by 4. Y is 6. Y means 6. 6 by 4 means 3 by 2. Right? Now 6 plus 3 by 2. 12 plus 3, 15 by 2. Okay, this will come in this form only. So better apply your logic, right? So let's see a question from the law of conservation of mass. See, 5 grams of KClO3 will yield 3.041 gram of KCl and 1.36 liter of oxygen at STP. Show that these figures support the law of conservation of mass within limits of plus minus 0.4% error. Why this error comes? Because of measurement errors. While you are measuring something, there will be some errors. You cannot make it 100% precise. But no mass is created or destroyed. Remember this thing. This error is just due to the error in measurement. The instrument you are using is defective, or the reading you are taking is defective. Okay, so 5 grams of KClO3, it gives what? This much grams of KCl, and the remaining oxygen means 5 minus this much must be oxygen according to the law of conservation. So this much of oxygen must weigh 5 minus 3.041. So let's work out this one. So according to gram molecular volume law, 220, you know that, I think you know this from your class 10, that 22.4 liter of all gases and vapors at STP weigh equal to their molecular weights, right? 1 mole, that is 22.4 liters, is equals to 1 mole, and it weights equals to its molecular weight in grams, obviously in grams. So weight of 1.36 liter of O2 in at STP, so 32 into 1.36 by 22.4. 22.4 weighs 32, so how much 1.36 will weigh? 32 by 22.4 into 1.36. It gives, this is the calculation I did. You will do better calculation, and never use calculator. Remember this thing. In JEE you are not used, don't make it a habit of using calculators. Be it a difficult calculation, but do it in hand. Okay, take approximations, small approximations, and do it in hand. Don't make it a habit of using calculator and saying it repetitively. So 13.6 by 7, it gives 1.943 gram, right? So let's move. Let's see now. So weight of KCl from is this much given. Where is the cursor? Oh my god. So this is given. So total weight of the product KCl plus O2. So this much. I said this is due to the error in the measurement of oxygen. Must be the oxygen. Some oxygen has escaped that we could not wait while doing the experiment. Some oxygen has somehow escaped from the container. Okay, so this error is coming. So error is, so error, how much is the error? 5 minus 4.9. This is the weight of the product. This must be 5, but due to error it is something this. So this much is the error. So percentage error is this much by 5. Total weight must be 5, but we had this much weight less. So this by 5 into 100. This I think you can do. I think Gabbar and Basanti also can do this one. So simple. The next law, the law of constant proportion. This also is a simple law. You'll understand from the definition only. It was given by our dear Joseph Proust in 1799. So what it states? It states that the same compound is always composed of the same elements combined together in the same or fixed proportion by weight. Okay, so I am reading it again. Listen carefully. It states that the same compound is always composed of the same elements combined together in the same or fixed proportion by weight. So obviously, in the same compound is always composed of same elements. Water will be composed of hydrogen and oxygen. You form water by mixing H2 and O2 and giving it a pressure, or by electric arcing, or you form water by mixing, by doing the acid and base reaction to form salt and water. There also the ratio, the fixed the ratio of H and O will be in a fixed proportion, that is 2 is by mass. Okay, so all the calculation they did there was based on their mass. Suppose H2O, you got H2O from what can I say, compressing oxygen gas and hydrogen gas in a beaker, okay, by applying pressure. And so here we have 2 grams of hydrogen and 1 atom of oxygen weight 16 gram. So what is the ratio? Ratio is 1 is to 8, right? And you got H2O from acid base reaction. Here also H is 2 grams and it is 16 grams. So we have 1 is to 8. Same ratio, okay? This is a very simple law. I think this law Basanti knows. I think Gabbar does not know this law. Okay, so now see the question. 0.7 gram of iron reacts with 0.4 gram of sulfur to form ferrous sulfide. This is given, means they have done some experiment and seen this one. Okay, now if 2.8 gram of iron is dissolved in dilute HCl and excess of sodium sulfide is added, 4.4 gram of iron sulfide solution is precipitated. Prove the law of constant composition. Now we'll get confused. भैया 2.8 ग्राम of iron कहाँ गया भाई? 2.8 ग्राम of iron को आप HCl में क्यों dissolve कर रहे हो? तो क्या होगा? Reactions क्या होगा? And excess of sodium sulfide is added. मतलब what will be the reactions? Okay, so the reactions, let us see what will be the reactions, right? बट मेन थिंग है तुम्हारा कि आयरन सल्फाइड 4.4 ग्राम हो रहा है. तो अब आप लोगों को एक कंफ्यूजन हो सकता है 2.8 ग्राम ऑफ आयरन ही क्या 4.4 ग्राम ऑफ आयरन सल्फाइड बनाएगा. सो लेट्स सी. सो द रिएक्शन इज, फर्स्ट ऑफ ऑल यू आर एडिंग Fe, okay, plus ACl. These all reactions you have to know. There is no chapter that you will learn in the inorganic chemistry. You will know all these reactions a bit, but some reactions you have to make it from your brain, why this is forming, why that is forming. So it will give FeCl2 plus H2 plus H2, okay, so 2Cl. Now FeCl2, what it will form? Pause the video and think. When it will react with sodium sulfide, simple displacement reaction will take place. Na2S, right? So it will form FeS and NaCl. Okay, so 2 NaCl. Now you have to consider that HCl is given in excess amount such that all the Fe is reacting. Nothing here is limiting reagent. Limiting reagent means if HCl is given very less and 2.8 gram is of iron is a mode, means some of iron will react with that much HCl and form something. You have to consider that HCl is enough. It is given in excess. HCl always is given in excess. So you get FeS. Directly all the iron is forming FeS. And also you have added Na2S in sodium sulfide in excess. So no question that this will be a limiting reagent. Okay. So it is very simple. all the iron is forming FeS. Now you see the ratio of weights of Fe in the first sample, that is known from the question, like this is, from this you know that it will be 7 is to 4. It is 7 is to 4. Now according to the second experiment, what you get that all the iron is reacting. So 2.8 gram of iron gives 4.4 gram of iron sulfide, or 2.8 gram Fe combines with S. So how much S is combining? 1.6 gram. 4.4 minus 2.8. So the take out the ratio, it's so simple. 2.8 is to 1.6, 7 is to 4. I think you will not see this video. It's so basic things are said here. So let's move to the third law. Third law and fourth law, you might get a bit that what is this, is how it is getting, but concentrate here, you will not get confused. So the third law, what it states? It states that if two elements combine together to form several compounds, okay, like hydrogen and oxygen, water, H2O2, hydrogen peroxide, okay, then the weight of one of these elements which combines with the fixed weight of the other are in simple ratio, are in the ratio of simple whole numbers. Then the weight of one of these elements which combines with a fixed weight of the other. Suppose take oxygen. Oxygen, what is the weight of oxygen? That reacts with 1 gram of hydrogen in water and hydrogen peroxide, in water and hydrogen peroxide. Okay, hydrogen peroxide, oxygen, how much oxygen per 1 gram of hydrogen? Here per 1 gram hydrogen, what is the oxygen's weight? 16 gram of oxygen is reacting with 2 gram of hydrogen, so with 1 gram of hydrogen, 8 gram, right? So simple, you know it will be twice. And with 2 gram of hydrogen here, how much oxygen has is combined to 32 grams, so with 1 gram it will combine 16. So what is the ratio between these two? 8 is to 16 equals to 1.2. 1 is to 2, sorry, 1.2, what am I saying, is equals to 1 is to 2. So simple. So it is a simple ratio, means it is not a complex ratio like 1 is to 1.21. Always this ratio will be a simple, like 3 is to 4 or 4 is to 5 maximum. That is also becoming complex. Ratio will never come in this manner, 1 is to 1.21, means it will be in a terminating fraction, it will not be in unterminating fraction. Okay, so let's see a question, then it will be a bit more clear, means you can grab the thing, it will be in your mind forever. So elements x and y form different compounds, we don't know x and y. In the first compounds, this much of x, 0.324 of gram of x reacts with 0.47 gram of y. In the second compound, 0.117 gram of x is combined with 0.509 gram of y. Show that these data illustrate the law of multiple proportions. Okay, so let's solve. So in the first compound, how much is combining with how much? 0.324 gram of x is combining with 0.47 gram of y. Simple. Now in the second compound, we need to make one of the compounds weight fixed. Suppose either x fixed or y fixed. For convenience, let's keep x fixed. Okay. So I am making the weight of x equals to this one. This much of x in the second reacts with this much of y. So this much of x will require, how much y this much of x will require. So this much of x combines with, say, 0.509 by 0.111 into 0.324. Why this one? See, this much of x combines with this much. So with 1 gram of x, how much will combine? This with 1 gram of x, this much will combine, and with 0.34 gram of x, how much will combine in this second reaction? Into 0.34. So this is the amount you get. Do the calculations by yourself, don't use calculator, okay? That will be a problem, means it will increase your skills only, how to do calculations efficiently and quickly. Now the weights of y that combined with the same weight of x, we have made it 0.324. Okay, that is 0.324 of it are in the ratio 0.471, here 0.471, and we have calculated 1.4095 here. So it is coming 1:3. So it is also a simple ratio. So it illustrates the law of multiple proportion. Now next, the law of equivalent, reciprocal, or combining proportions by weight. It was given by Richard in 1792. Focus here carefully. It states that if two elements A and B combined with a fixed mass of element C, two element, okay, suppose NH3 and we take NO3, okay, two elements, and here suppose A is, this one is H is A and O is B, okay, and what is the fixed element? Suppose N is the fixed element, that is C, okay. Then the ratio of A and B in these compounds is same or simple multiple of the ratio when they combine with each other. Now when oxygen and hydrogen combine each other, let's say it forms water, what is the ratio in which they are combined here? 3 grams of hydrogen here is to 3 into 16, 48 grams of oxygen here. So it is coming to be 1:16, right? And see here, in water, how much gram of oxygen is there? 2. With how much oxygen? 16, equals to 1:8. So isn't it a multiple? This one isn't it a multiple of this one? Means it is combining with 16 and it is combining with 8. So 16 is the multiple of 8. Either it will be same 1:8 or 1:8. Either it will be a multiple. Okay. So you will better understand through a question. So let's see the question. See here, they have not given how much mass of nitrogen is reacting with how much mass of hydrogen. They have just given the percentage. Same, you can calculate the mass, how much mass is reacting. Suppose this one, how much of nitrogen is there by total weight of the compound, by total, say total 100% into the total weight of the compound is NH3. How much it is? You say 3 plus 14, 17. So you'll get the nitrogen weight. So no need to convert it into mass. Keep it in this way, because when you are calculating the ratio, why is the cursor? When we are calculating the ratio, these things will cut out. So keep it in this form. Oxygen, this much of nitrogen and hydrogen. Ammonia contains. Water contains this much of oxygen and this much of hydrogen. Nitrogen dioxide contains 63.13% of oxygen and 36.85% of nitrogen. So by calculations from these data, which chemical combination is verified? Now we see how the question will come in the exam. This will be given this data and they will work out the answer. Means they will give the answer, they will work out, and they will say that which law of chemical combination is verified here. Now they'll give 4 options, the before 4 options. Now you have to tick the correct option. This type of question may come, typical question. I am sorry for you. What can I do? We have to remember the name. The ammonia contains this much nitrogen and this much hydrogen. Now the weight of nitrogen that combines with 1 part of weight of hydrogen. So this much parts and this much parts they combine. So with 1 part of hydrogen, how much nitrogen combines? 4.67. So 8 to 2.35, this by this. So you'll get with 1 part how much nitrogen is combining. So 4.67. Now with water. In water, H is this much and oxygen is this much. Same weight of oxygen that combines with 1 part by weight of H in H2O. So I have kept the ratio, I have kept the percentage only. I have not calculated in weight because I said that the ratio will cut out. You are intelligent enough to figure out that. So it will be 88.90 by 11.10, say 8.01. Okay. So what is the ratio now? In the two compounds NH3 and H2O, the weights of nitrogen and oxygen that combine with the same weight, that is 1 part by weight of hydrogen, are in the ratio 4 is to 8.01. It comes out to be 1.71. This is the ratio one. Remember this one. What we have done here in H3, we have seen with one part of hydrogen what is the weight of nitrogen that is combining, and next part we are seeing with one part of hydrogen in water how much oxygen is combining, that is 8, this one, and we have taken out the ratio. Now we move to nitrogen trioxide. It is given the percentage. In this compound, the ratio of weights of nitrogen to oxygen is this much is to this much. So the ratio comes out to be 1.71. 1 is to 1.71. So it is exactly equal. So the law of reciprocal weights is verified, right? I also don't remember the laws. Oh, typical names. So the law of equivalent or reciprocal or combining proportions by weight. ठीक है? तो 4 लॉ हो गया है, और फिफ्थ लॉ आई थिंक यू हैव स्टडीड इन योर class 10 and you will do that better than me. So the fifth law, don't laugh, okay? I know you are very dirty minded, don't laugh. Gay-Lussac's law of gaseous volumes. So let's start. It was given by Gay-Lussac. It states that when gases react together, they do so in volumes which bear a simple ratio to one another and also to the volumes of the product. Means suppose oxygen and hydrogen reacting. Suppose H2 and O2 is reacting. Now it gives H2O. You do the balancing. Here it will be half. So let me give here 2, here 1 and here 2. So it is balanced. So see, what is the ratio of volumes? Here 2 volumes of hydrogen will react with 1 volume of oxygen to give 2 volume of water if it is steam. If it is steam, also to the volumes of the products if gaseous. This has to be gaseous, okay? These two has to be gaseous because it deals with gases only. If gaseous, all measurements being made under similar conditions of temperature and pressure. It can be any pressure, but when you are measuring this, suppose under some pressure P, you have to measure the products also under the pressure P and the same temperature T. Okay? Now let's see a question, and last question. So see the question. What it is said, air contains 21% oxygen by volume. Calculate the theoretical volume of air which will be required for burning 500 cubic feet. Don't get confused or tensed by the unit. Give your answer in the same unit. Do all the calculations in the same unit, and if it is said to convert, convert at the last. Don't convert it first. Of acetylene gas, all volumes are measured under the same conditions of temperature and pressure. Okay, so the condition of Gay-Lussac's law is mentioned here. So let's see the solution. C2H2, first let us balance the equation. I have taught how to balance. See the carbon atom 2, 2. Now see the hydrogen. Hydrogen is balanced already. So you count the oxygen 4 plus 1 5. So you need 5 here. It has 2 already, divided it by 2, multiply it with 5. So the final equations you have here. So 2 molecules reacts with 5 molecules of oxygen to give 4 molecules of carbon dioxide and 2 molecules of steam. Okay, that means if all are in gaseous form, 2 volumes of this one will react with 5 volume of this one to give 4 volume of this one and 2 volume of this one. Okay, Gay-Lussac's law says that if you have 2 volume of this one at STP, or you have 2 volume of oxygen at STP, you will have the same number of molecules. If it has 2 volume, okay, you don't have much, means you don't have enough volume, you have only 2 volumes, here also 2 volume, here also 2 volume. So this is the reactions, but the number of molecules, say this is X number of molecules when it is 2 volume. If oxygen is 2 volume, it will be X number of molecules. Okay, so see, here it is the ratio. Here the ratio of the reacting molecules and those of the products is taken as of their volumes. This is in accordance with Avogadro's hypothesis, right? Equal volumes of all gases under similar conditions of temperature and pressure contain equal number of molecules, that I explained you before. Or its reverse is also true. It has to be. Namely, equal number of molecules under similar conditions of temperature and pressure occupy equal volumes. If you have equal volumes, it will have equal number of molecules. If you have equal number of molecules, it will have equal volumes. Or if the ratio is something, in that ratio only will be the volume. If their volume ratio 2 is to 5, then their molecules ratio will also be 2 is to 5. If their molecule ratio is 2 is to 5, conversely their volume ratio will also be 2 is to 5. Okay, so what is happening? So according to the above equations, we have 2 volumes of acetylene requires 5 volumes of oxygen for combustion. Therefore, 500 cubic feet of acetylene will require how much oxygen? 2 volumes require 5 volumes. So 500 will require how much? You say divide it by 2 and multiply it with by 5. Divide it by 2 and multiply it with by 5. So simple. This much oxygen is required. Hence the quantity of air required 21% in air, 21% is oxygen and the rest we don't know. So divide it by 21 and multiply it with 100. So this much oxygen we require in cubic feet. Okay, it is in cubic feet. Cubic feet. If you at last it is said you to convert it into liter or something, you have to know the units. Okay, so this is the end of a very boring lecture. This part is very boring, I also accept it, but be prepared or be focused on the next video, because next I will teach molarity, normality, n factor, and that is recorded in every chapter. So be there, okay? Don't get bored that physical chemistry is so boring. The cert, the bhaiya teaches so boring. Who will read all this? This is so simple. Don't do like that, because you need to understand n factor, molarity, and normality. That is will be recorded in every chapter.